Welcome to this live stream. I'm delighted to be again with Professor Scott Turner. How are you doing, Scott?
Great, thanks, Sibwer.
So, we haven't been live for a while. You've been quite busy. What have you been up to?
Well, aside from the normal writing and whatnot, I've recently just come back from Dayton, Tennessee, which is where the 100th anniversary of the Scopes trial was being celebrated. I was down there filming for a documentary that we're going to be putting out soon at the National Association of Scholars. One interesting thing that happened was the day after. A group of people from the Freedom from Religion Foundation who had been holding their own 100th anniversary symposium in Chattanooga, which is nearby Dayton. They came in for their own rally, and our friend Richard Dawkins did make an appearance. Unfortunately for him, the technology failed him and his microphone kept cutting out. But that was an interesting end to an interesting contrast to what I saw from the people of Dayton itself.
Brilliant. And when will this documentary be published?
Well, it depends upon how quickly I can get the footage hammered into something that's coherent. So I'm looking at maybe a couple of weeks before it will go live. Yeah.
Brilliant. Now, you've written this article, and this is something I've been waiting for a long time, Bubbles and Darwinian Daydreams. So this is a response to Dawkins' latest book. This is actually, to my knowledge, and you can correct me if I'm wrong, the only official academic response so far, because it's a recent publication.
As far as I know, yes. We got an advance copy of it, of course, and Peter Wood, our president of National Association of Scholars, said, "Oh, you have to review this for us," which I did, and quickly read and put out this review.
Brilliant. Also, I wanted to mention something. Since you mentioned Dawkins and you mentioned the Freedom from Religion Foundation, maybe, when speaking about the neo-Darwinian bubble, we can go into the history of these bubbles. So you mentioned how natural theology was also a bubble, which was then burst by Wallace and Darwin, and then you had another bubble. And maybe it'd be nice to get a bit of a history here of bubbles.
Sure. An epistemic bubble is as I mentioned in the review, basically a group of people who have one particular view of the way the world is, and they associate naturally with other people who agree with them. And with that usually comes a set of inquiries, looking at evidence, those kinds of things. And the initial response is or the initial motivation is to try to boost what is a beautiful idea. And prior to the Darwinian idea, for a few centuries before that, the beautiful idea was natural theology, that the creations of the creator are a worthy object of study and inquiry in themselves, primarily because they tended to demonstrate the wisdom and omnipotence of the creator. And of course, William Paley was one of the principal organizers, or one of the principal thinkers in that. But the roots of natural theology go back several centuries into some actually very interesting disputes among the Christian churches, not only within the Catholic Church, but also with the rising Protestant denominations coming in then, about what is it that we should be, what should our relationship be with the natural world? Is the way to God looking at revelation, or is it engaging with the natural world? It is with His works, and that was a very powerful epistemic bubble, and part of what held it together was this coherent mindset that even though you had disputations occurring within it, nevertheless, it was all united by this very beautiful idea of nature as evidence of the Creator's works. that was burst in the early 19th and middle 19th century by several naturalists. It was starting to inflate beyond tolerance, and that burst. And now the only remnants of natural theology that you tend to see is the kind of warmed over version that you see in things like intelligent design theory, for example. It's very similar to the kinds of things that William Paley was arguing, similar logic, but with a modern science gloss to it. Now, the Darwinian idea is another very beautiful idea. It's a very powerful idea, that you can explain the diversity of life by this simple mechanism of natural selection. You don't need any kind of intervention of a creator to have that happen. And of course, this was an idea that captured the natural sciences almost completely. And so that's another example of an epistemic bubble. Now, modern Darwinism is that as well. The Darwinian idea itself went through some rather tough times in the late 19th and early 20th centuries, to the point where it was looking like it was almost discredited. This is called the eclipse of Darwinism, and it was pulled out of the fire by this idea that was advanced by Ronald Fisher and others, that, well, you could actually rescue the Darwinian idea by tying it to gene pools and Mendelian genetics, and that's another very powerful epistemic bubble. Now, the thing in modern Darwinism, we're actually in an epistemic bubble, and we've seen this in some of our conversations with people that we've had on this on this podcast, namely Massimo Pigliucci, and the in the Darwinian epistemic bubble, everything makes perfect sense. If it's going to be explained, this is the explanation for it. If there's something that's unexplained, this is the explanation for it. We just haven't got there yet. And we don't need to be mindful of evidence from other areas of intellectual inquiry. And I just want to add to this that every scientist, every human being, in fact, inhabits an epistemic bubble of some sort. And we make progress actually when you start getting conversations across epistemic bubbles. That is, when you kind of pop the epistemic bubble and you open up conversations. Of course, this is what Thomas Kuhn identified as scientific revolutions. You've done the normal science, which is, putting the beautiful pictures on the walls of the epistemic bubble, seeing it all makes sense, but little contradictions build up and build up and build up until finally the bubble pops, and then you have to actually create a new epistemic bubble. So there's nothing wrong with epistemic bubbles. It's just a natural part of the way we engage with the world and engage with each other. But what science should be doing is actually trying to open up epistemic bubbles, trying to pop them at every opportunity that you can. That's where the contradictions build up in Kuhnian normal science, and also to talk across epistemic bubbles. Basically, what Stephen Jay Gould called, the non-overlapping magisteria. When you're talking about magisteria, that's one thing, but when you actually are defending non-overlapping magisteria, that is no conversation between the two magisteria as he identified it, of religion and science, then you build an epistemic bubble and you actually try to reinforce rather than pop it. And as I said, Darwinism is probably the most strenuously defended epistemic bubble in modern biology, and Richard Dawkins has long been one of the most ardent defenders of keeping that epistemic bubble closed.
Yeah, and I love the way that you summarized the power that they give to natural selection. You write that natural selection is granted agency that rivals the hand of the creator God. So just like in the 17th century, whatever someone would see, a natural philosopher would say, well, that's because of God and that's because of God. Okay, we have something which we don't understand, that's still God, and that's still the Darwinian paradigm. There was one point I just wanted to ask you about this. When you had your discussion with Piglucci, which was quite lengthy, there was one point that stood out for me, and I guess that's linked to epistemic bubbles. It's when you pointed out, well, gene-centric theory has dominated the thinking here. And, Massimo, I believe, was saying something to the effect of, well, we've moved on from that. And then later on in the discussion, when it came to, I don't know, abstract concepts of what units we break things down to, then you pointed out again, well, you're just going back to that level of abstraction, right? So
Mm-hmm.
I think for me, correct me if I'm wrong, but that seemed to be an example of an epistemic bubble, because we're saying, no, we've moved away from this, but then when we get stuck, we just go back to it.
Yeah, that's certainly part of it. And you see the evidence of an epistemic bubble in arguments that, well, if you want to intrude your way of thinking into this, then you need extraordinary proof to be able to gain admission to the club, so to speak.
Yeah.
Meanwhile, within the epistemic bubble, and Richard Dawkins' book has lots of examples of this, the most, I don't want to say outrageous, maybe outlandish, maybe extraordinary claims for support are made that actually don't really hold up very much. And the the most clear evidence for that to me was when in the book Richard Dawkins was talking about the convergent morphology of ichthyosaurs and modern day dolphins and porpoises. They have very similar body forms. It shows the mark of different inheritance. The ichthyosaurs had tails that waved back and forth laterally. Dolphins have tails that wave back and forth vertically, and so forth. But the explanation is that, well, natural selection shaped the morphology of those two things because they're shaped by similar forces. Okay, well, all right, that's one explanation, but you just have to believe it, if you want to delve into it. Well, just how does an ichthyosaur genome turn into a dolphin-like creature and a dolphin genome turn into a ichthyosaur-like creature? How does that work? And there's this kind of vast territory that's just unknown territory that's just accepted. You just have to accept it. That's all there is to it. And if we don't understand now, we will eventually. And
Yeah.
okay, I'm not so sure about that.
Yeah, it's almost like, I believe it was Gould or Eldridge, I'm trying to remember who wrote this many years ago, that providing a coherent, consistent story does not mean you've provided evidence. You've just provided
Right.
something consistent. So before we get into the problems with the book, I wanted to ask you about the metaphor of the genome as a palimpsest. What is that metaphor, and is that his basic idea in the book? Is that what he's really relying upon?
Yeah, I mean, this is the paradoxical aspect of Richard Dawkins' writing. He's a brilliant writer, very creative in many ways, but still stuck in this epistemic bubble. So, for example, the selfish gene, absolutely a brilliant way of expressing the neo-Darwinian way of thinking about evolution. Same thing with the concept of the meme. That was actually introduced in his book, The Blind Watchmaker, I believe. And so he's always impressed me as an impressive writer. And his first two books, Selfish Gene and what was the other one? I think it was The Extended Phenotype, came out when I was in graduate school, and I was just absolutely captivated by them. And he retains this remarkable talent of being a brilliant writer and being able to explain things to the general public that are very understandable and very compelling. His most recent book, which is called The Genetic Book of the Dead, A Darwinian Reverie, in that book, Richard Dawkins speaks about the genome as a palimpsest, and just to elaborate on that, a palimpsest is a term derived from the world of art and also deciphering manuscripts. In the Middle Ages, for example, when monks would be sitting in their monasteries transcribing ancient texts, they would do this on vellum, which is basically sheepskin, and vellum was very expensive, very hard to get. I mean, you had to murder sheep to be able to get it, and so when you had vellum that was written over, but what was written there was no longer really considered all that important, the monks would scrape the old writing off, basically scrape the old ink off, and write over it. But there would always be a trace of the previous writing on there. And so the metaphor that Richard Dawkins built here is that, well, the genome is kind of like that. At every generation, the genome is a reflection of past genomes. The genomes are passed down, and by genome I mean basically sequence information of nucleotides and nucleic acids. At every stage, if there's a mistake or there's an error or a change made, that's written over the previous genome. And what Richard Dawkins is saying, which I think is actually the most compelling aspect of this book, is that you can read a current genome, but that's always going to reflect what's been genomes in the past, and therefore the current thing that we see is a palimpsest of past genomes, which is an intriguing idea, and where that becomes most interesting to think about things is that you can use DNA sequence, for example, as the precursor to function, which was the conventional way of looking at DNA from the 1950s onwards. The whole central dogma of Francis Crick, the gene sequence goes to working memory and RNA, goes to protein, which ultimately leads to function. That's still a kind of a vast unknown territory, but where DNA sequencing has become really, really, really interesting is that you can actually use a genome as a historical record. And this is where this palimpsest metaphor comes in. You have the superficial that is present DNA, but always within that genome, there's going to be remnants of genomes in past organisms. And you can use that to reconstruct actually an evolutionary history in a different way. And of course, the example that I use in the review, and that was featured quite prominently in Dawkins' book, is where did whales come from? I mean, whales are the most improbable creatures that you could imagine, and it becomes more improbable still when you look at the ancestry of whales, which can actually trace its roots back to the pigs and the ungulates and so forth. So you have this incredible weird story that you had creatures that would graze on savannas and somehow they became filter feeding sonar directed whales. How do you do that? And in the past, scientists would always rely on differences of morphology. Well, here's this little crook on a bone, and we see this in this creature, and then we see remnants of it in another creature, and therefore that indicates some kind of an evolutionary connection. And when you have fossils that can help fill in the gaps between past and present, then you can actually use that as morphological evidence and so forth. But the trouble with morphology is it always relies on kind of very subjective things like what's the curvature of this part of this bone, and what happened to that bone as ungulates made the transition to whales. And you can use genomes actually as an independent and objective record of what the layers of descent are, or what the pathways of descent are. And it turns out that based on morphology, it looked like the whale had a common ancestor with pigs and peccaries. But if you look at the genome, it looks like their common ancestor actually is through the hippopotami, and so you have a different kind of picture of the evolution of whales from that. Recently, actually, the ability to sequence genomes, and of course, this is all thanks to Kary Mullis and the polymerase chain reaction. Anthropologists have been doing some amazing work trying to reconstruct the genomes of humans as they moved out of Africa, as Homo sapiens moved out of Africa into Europe and Asia, where you had for a time the coexistence of Homo sapiens. You had the Neanderthals in Spain, and actually basically along the northern Mediterranean coast, and then the Denisovans, which were further up near the Caspian Sea. And you can actually trace out genetic relationships between them, and you can see that, well, they have similar relationships. Every one of us carries around some segment of Neanderthal DNA, and it's to the point where you can actually extract DNA. There was one that I read recently where you can say that, well, the skeleton of this child right here had one Neanderthal parent and one Homo sapiens parent. And so the ability to reconstruct evolutionary and reproductive relationships is just incredible. It blows my mind, to tell you the truth. And this is the really powerful power of the metaphor of the palimpsest. You're actually able to take DNA and look at past evolutionary history, and of course that's a fascinating thing. It has nothing to do, and it doesn't validate one way or the other, the whole notion of Darwinian natural selection, right? It doesn't have any evidence of that at all. So this tool that was looked upon with such great promise in the 1950s. Here's the genetic molecular proof that genetic natural selection works. It hasn't really worked out that way, but it has proven to be a very, very powerful tool for reconstructing evolutionary histories. And this was in part, I think, the reason why Richard Dawkins wrote this book.
Sure. Just wanted to ask you a follow-up question, because you said something interesting there. The importance of making a distinction between the Darwinian mechanism and the homologies that we see is a very important distinction, because, like you pointed out, none of that goes in any way to support the Darwinian mechanism, because Darwin's theory was not a theory of similarity, it was a theory of transformation. However, I did feel, and I wanted your thoughts on this, and you've read Dawkins for decades now. I do feel he doesn't make that distinction clear to the readers. There's a shift between, it's almost like the evidence for Darwinism is the evidence for evolution.
And he's speaking to the people, his co-inhabitants of the Darwinian epistemic bubble.
Yeah,
of course they're going to. It's all a beautiful idea. It's all so consistent, and if it doesn't make sense now, it will. Take it as faith. So,
yeah. So let's get back to an important question, which is, you explained obviously the metaphor and the importance of this actual metaphor, but can you elaborate on your perspective about reading Dawkins not fully adhering to the palimpsest metaphor in his latest book? So you go on to explain how It's almost like his latest book is a pageantry of all his other stuff over the years, and it doesn't stick to its own original what it says on the cover.
Uh, yeah, about half of the book explores this interesting palimpsest metaphor, but after that, it kind of turns into something like this year's Barbara Streisand final tour. It's meant to play to the audience. He basically goes through his greatest hits of the past. The extended phenotype makes an appearance. The selfish gene shows up. Even the blind watchmaker comes in, and this is where I think the book tends to fall down. Those have always been issues for me anyway, with the whole neo-Darwinian idea. Okay, that's a brilliant idea. Let's put the test to you. Where's the evidence for it? And what we get really is, well, all right, we don't know yet quite fully, but we will soon. Just hang in there. If you have this question like the convergence of ichthyosaurs and dolphins, it just does. Don't worry about exploring that too deeply, because it just does. It has to be that way, or explainable that way, and that's where I was a little disappointed in Dawkins' work, because these remain unresolved issues. These remain issues that are at the heart of what sustains the Darwinian epistemic bubble, and there's lots of things out there that question that, but they're not admitted, of course, because of the Pigliucci standard that you have to have extraordinary evidence to be admitted to the club. And if never mind what evidence that you have, if it's not evidence that we can engage with or that we think is worthy, then you're not going to be admitted to the conversation.
Yeah, I feel there's an inversion of the onus of proof. So it's almost like, okay, so you need to prove why this coherent story cannot possibly be coherent, as opposed to providing evidence for it. There's another thing, I didn't mention this to you before we started the interview. Apologies, I should have. He dedicates a chapter to Noble and the debate that they actually had. And I remember approximately, it's been maybe 2-3 years since the debate, and he didn't actually speak about this topic at all. And he simply, with that famous Forbes interview that was conducted, he responded to the Forbes reporter that, look, my latest book is going to respond to him. I felt he didn't actually bring anything new in the chapter in which he was addressing Noble. He simply restated his points about genetic determinism, his points about the causal the genes being the primary active causes, and in terms of all of his claims during the discussion about when Noble brought up the issues of genetic assimilation and all of those points about holism and why reductive biology is wrong, I just felt he simply didn't add anything new in the chapter on Noble.
No, and this is this is the fundamental, I think, contradiction that's afflicting modern biology today, modern evolutionary biology today, and what constitutes good evidence. And I think it all turns on the question of whether you believe that the genes are the driver of evolution. And of course, in the logic of neo-Darwinism, they are. They determine function, which is then tested by interaction with the environment. And some get lucky and reproduce, and some don't. And that's sufficient explanation for everything. uh, in instances like the extended evolutionary synthesis, the advance has mainly been, well, of course we recognize that behavior is important, or of course we recognize that developmental biology poses some interesting challenges to the gene selection idea, and so on and so on. But we we get to the problem that we've already discussed, namely that the reversion is always back to the genes. That there have to be genes for this, and this, of course, is the reflection that genes are somehow determinative of function. Then you have on the other side, and this is the real problem, I think, in modern evolutionary biology, is that you have people like Dennis Noble or people like me, I have to say, who are saying that, well, maybe we have this backwards. Maybe it's not it's not the genes that drive lineages forward in time, but maybe it's organisms themselves which drag genes along in their traces. Its idea back to this common ancestor, if you will, of Barbara McClintock, saying that the genome is the organ of the cell. It's as involved in the
Yep.
physiological function of the cell as anything. It's not a determinant; it's a participant, and that just changes the entire landscape of the kinds of drivers of evolution. And I don't know the extent to which Dennis Noble buys into this doctrine, but for me, anyway, the real parting point or point of departure is that I've come to think that things like intentionality, purposefulness, intelligence, they're not only not apparent, but they're quite real, and that's the main failure of modern evolutionary biology, is that the entire thing is devoted to actually excluding those fundamental aspects of life. And I think Dennis is sort of there as well. I'm not sure. I might be a little bit more radical on this than he is, but that notion of intentionality, of purposefulness, of introducing that dread word teleology or vitalism into the discussion is just something that I think completely undercuts the Darwinian mindset, which is that you have these genes that determine function that then determine selection, right? I think it's
Yeah.
function that actually determines selection. The natural selection is not, well, let me just say, selection is not natural. It's quite purposeful and deliberate. And of course, that undermines the whole Darwinian idea.
Yeah, it does. And I don't think things have changed since the time of JBS Haldane when he said, teleology is to the biologist a mistress. He can't live without her, but
Right.
he doesn't want to be seen with her in public. I wanted to
Exactly.
ask you the question about one of the statements in the chapter in which he is addressing Noble. He says
Mhm.
something which is quite striking, and I believe it's a powerful appeal to authority. He says, if genes are not active causes in evolution, almost all scientists now working in the fields of behavioral ecology, ethology, sociobiology, and evolutionary psychology have been barking up a forest of wrong trees for half a century. And he said something to the same effect during the discussion. And I'm sure someone watching this live stream may say, well, Professor Scott is going against the consensus. Everybody assumes the genes are the active causes. And it's a very powerful point when they put it that way.
Yeah, it is, and I'm not sure I would say that everyone's been barking up the wrong group of trees, but they've been barking up uh, a grove in a rather complex forest, right? That okay, genes. There's no doubt that they function importantly. There's no doubt that they get modified, and that modifies function. There's no doubt about that at all. But what you have there is you have this grove of trees that's focused on action of genes, and we're learning a great deal about this. I'm not denigrating that field at all. But then what about behavior? What about the purposeful behavior of organisms? You know, the idea, and this traces back to Richard Dawkins' other metaphor of the organism as the vehicle for genes, and that's actually the genes as the unit of selection. You know, I don't think that's right. I think that introduces an arbitrary division between genome and phenome.
Yep, yep.
I'd like to think that Barbara McClintock would agree with me that there's no real distinction to be drawn between the genotype and the phenotype. And when we take that distinction away, then the function of the organism and its unique properties, among those listed, I've already said intentionality and purposefulness, frank purposefulness, start to become important. And what that does is it broadens the aspect of what hereditary memory is, right? And in the Darwinian gene-centered conception, Darwinian memory is whatever is inherited in the sequence of nucleotides in DNA, right? That's what's inherited. In addition to the kinds of epigenetic modifications that depend upon function and life history of an organism, an individual experience of an organism that results in epigenetic inheritance, now you've got an entirely new dimension of evolutionary heredity, of what it is. And it's not just a sequence, it's also the kinds of physiological modifications, epigenetic modifications that can be passed on across generations. And then if you start looking into what the actual interaction is between an organism and its environment and the organism's ability to modify its environment, then the range of hereditary memory expands dramatically. You know, you include things like language, you include things like modification of ecosystems, like I've outlined with the termite and social insect colonies, how they modify their environments. If these things are very long lasting compared to the generation time, these modifications are long lasting with respect to the generation time of the organism, those are hereditary memory, you know, that influence function in future generations as much as variations in DNA sequence do. And so, yes, there's gene selection that's going on. I'm not sure it's just a simple interaction of organism with environment that does it, but it's there. All right, it's a function. It's a form of hereditary memory, and that's going to tie into the whole evolutionary thing. But now you have things like language, you have writing, you have social constructs, you have environmental modification, and these things are forms of hereditary memory as well. And who knows how the proportion or the importance of those things will portion out as we understand how this is. But I think that actually where DNA sequence has been the prime source of hereditary memory that people think about, I think you're going to see a vastly expanded range of hereditary memory. And the end result of that is you're going to come to the conclusion that the genes are not driving evolution. The genes are being dragged along in the wake of physiology. And you know, and of course that just inverts the whole Darwinian idea on its head, I think.
It does. It does. And also something else, which Noble, the two Nobles, Ray Noble as well, in their book Living Systems, point out is how Dawkins shifts the term gene for the particular context. So he would use it as a strand of DNA, but he'd also use it for anything that is inherited. And so I wanted you to speak on this this very slippery issue of the gene. You write that we no longer have a clear picture for just how nucleotide sequence translates into function, nor do we have any longer a clear understanding of what the gene is, or even if the gene exists at all.
Yeah, I mean, it's again, this is one of the fascinating developments that's been playing out in molecular biology and molecular genetics. The more we delve into the translation of DNA sequence code into function, the more complicated it gets. And the the whole idea, the whole concept of epigenetics, which has been around since the 1950s, basically, that w- when you look at the steps between DNA sequence code and translation into function, there's very complicated layers of editing, of splicing of RNA, of segments of RNA feeding back and manipulating sequence transcription, and so forth. And these things elaborate more. The more we study them, the more they seem elaborate. And the overall consequence of that has been to basically close the loop on the central dogma of DNA, where central dogma of molecular biology, I should say, that it's not simply a one-way translation of DNA to RNA to protein and then in some vague way to function. What this does is it closes that loop. Not only does DNA influence RNA and RNA influence protein, but you have all these feedbacks where proteins can manipulate what's transcribed. That is, you're basically defining the gene on the fly, so to speak, so that the same sequence can result in several different proteins and variation of function, those kinds of things. RNA can feed back onto DNA and influence where transcription does. So this whole notion of the gene, which was originally conceived as a discrete sequence of DNA punctuated by start codons and end codons, that's gone. Who knows where the functional part of DNA extends. It can be these kinds of fixed genes, but then you have all this other sequence code in there, including things that have traditionally been derogatorily called junk DNA. It turns out it's going to be very functional in translating sequence code into function, and so we're ending up with this kind of nebulous concept of the gene, to the point where do we really understand what a gene is anymore? And I think Evelyn Fox Keller actually addressed this long ago, that the whole notion of the gene, that is a discrete gene on a bead, so bead on a string, so to speak, is not going to stand for very long in the face of increasing knowledge about DNA. So what is emerging is that again, we come back to the brilliance of Barbara McClintock and formulating this idea that the gene is an organ of the cell, right? It participates in the physiology of the cell. It's not simply just memory of past generations. It actually is a functional part of the cell and is subject to the same physiological influences that affect everything else that's going on in the cell. And the end logic there is that, well, we don't actually know what a gene is anymore.
Yeah, we don't. And also the gene's relationship with behavior has been, popularized in terms of the blind watchmaker narratives in a way that is so deterministic. But, you in your article, you explain, using the example of the mole cricket, to give a different paradigm in terms of the relationship between genes and behavior. If you could please elaborate on that example.
Okay, so mole crickets, just for the sake of the listeners here, is that it's a group of crickets. Obviously, they have a habit of creating burrows in the ground. Like all crickets, males set up stations where they stridulate their wings and generate sounds to attract females. There's all kinds of fascinating acoustics that goes on behind translating that muscular action into a sound, and that happens within the nervous system of the cricket. There's programs for firing the locomotory muscles in particular ways to generate the sound. And of course, there's morphological things. You have the comb on the cricket's wings, male cricket's wings, and so forth, that actually generate the sound. And crickets actually do a remarkable set of behaviors that basically improve the quality of the sound. Physically, just on their own, crickets should not be able to translate this back and forth motion of the wings into the sounds that we hear. There's all kinds of acoustic tricks that go into it. The typical trick is for the rest of the cricket's wing to turn into a resonating membrane that is excited by the movement of the wings across one another. But there are a whole bunch of other interactions that go on that tend to amplify the sound. One simple one is for a cricket to just crawl up on a leaf, for example, right? That can help improve the translation of the energy that goes into creating the sound into kind of a far reaching sound that will attract lady crickets to that male. There are other things, cutting a single hole in the leaf that it's sitting on can actually amplify the sound even further. It basically acts like the baffle of a speaker. Now, mole crickets, they take it literally to the next level. What they do is the males create a singing burrow, and if you take a cross section through this singing burrow, it has a very close correspondence with the shape of an exponential horn, like you see in brass instruments, for example, or in any kind of wind instrument. There's usually some kind of a exponential flare of the horn. And acoustically, what that does is, for the trumpet, for example, is it takes the rather, chaotic noise that comes out of a trumpeter's lips, for example, and turns it into a pure sound. It reduces the broadband frequencies of the sound that's coming out of the lips into a single tone, usually a tone plus some overtones and so forth. What that does is it concentrates the energy into that frequency, and it makes it a louder sound. And of course, this enables the cricket to broadcast its call to a wider area, and it also means that it will attract, or at least be sent out to more females than necessary. And by tuning the frequency, it also tunes it to the hearing organs of the female. Now, in the genetic book of the dead, Richard Dawkins brings this up, and the implication is that, well, isn't this a wonderful thing? And it is a wonderful thing to behold, and then he goes back to genetic natural selection as being the cause of it. That all you need to explain it is that, oh, well, if you do this, there'll be a gene for constructing a burrow, genes that enable burrow construction that more closely resemble an exponential horn will confer a reproductive advantage on the male that does it. He'll be more likely to mate and send, blah, 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 send those genes on to the next generation. And you get this kind of natural selection refinement of the ability of the cricket to build this exponential singing burrow, exponential horn singing burrow. The trouble with that is it doesn't really get into the dynamics of the individual male cricket. And Henry Bennett Clark, for example, many years ago, did a remarkable study of just how it is that these crickets build this burrow. And he found that it was a process of active tuning. So what happens is that the male cricket digs a burrow, it flicks its wings back and forth, generates a sound, and the cricket listens to it. And then if it's not to the cricket's liking, the cricket will get busy remodeling the burrow, does another cricket, listens. If it doesn't like it, it remodels further. And eventually the sensory perception of the self-generated tone, combined with basically, do I like the sound of this or not, results in an active process of this cricket building building the shape of a burrow that helps produce a sound that the cricket likes, right? And I don't know of any other way to express it than in those terms. And so it's a very intentional process. Uh, it's very similar to the kind of intentional process that goes into tasks that we make. The kind of tinkerer kinds of things. There's an inevitable inclusion of not only sensory perception of the world, right, uh, but also exploiting modifications of the environment to change the sensory perception, and it all converges on basically what the cricket wants his sound to sound like. And you can build all kinds of models for saying, oh well, there's a gene for building an ear, and there's a gene for making neurons especially responsive to one frequency, and there's a gene for this and there's a gene for that and so forth. But I haven't seen any evidence that really that there are genes, that anyone has identified genes to the point where that explanation suffices. A far more powerful explanation is that this construction of a tuned singing burrow is at root an exponential process, right? There's just, I just can't get around it, and to me that's a simpler explanation. And a Darwinian might say, oh well, this is the problem with your point of view. You have a simple explanation, then you stop inquiring about it, whereas we're still in there, doing the good fight. And uh, okay, but isn't the whole point to understand what it is that's driving evolution, right? Isn't that the whole point? Yeah, and that to me was a prime example for how someone can be stuck in a beautiful epistemic bubble and come away with less knowledge than if you just look at it from outside. And if you look at it from the perspective that actually it's the organism, I use this metaphor a lot, dragging the genes along in its wake. That's the real thing that's determining the progress of evolution going forward.
Yeah, that's a really fascinating process, especially the way you described it. I was just thinking about, it's almost magical, but it's just the Darwinian faith allows these consistent, coherent stories to just be imprinted on it, and everyone just accepts genetic determinism. And clearly, there's a lot more going on. There's a lot more. I mean, it's basically a holistic imprint can be applied. It could make a lot more sense of the data. The way that you end your review is it's a good summary. So you say, to those who are permanent residents of the Darwinian epistemic bubble, the genetic book of the dead will be an eloquent defense of the Darwinian faith. It will be seen as eloquent because it is internally coherent and therefore beautiful. Now, this is something I've said a few times, and you've said a few times as well, which is for them, something coherent and consistent that seems to be evidence. To those who found themselves, as I have, on the outside of the Darwinian bubble, the genetic book of the dead will jar the eye and mind, like watching a beautiful ballerina whose tutu has slipped to her knees. Now, talking about change and future, I was reading recently about Carl Woese, and near the end of his life, he had this regret. And this is in the book, The Paradigm Shifters. And he basically says that one of his regrets is that in his lifetime, he did not see the hegemony of Darwin being overthrown. Now, he famously endorsed, James Shapiro's work, his 2011 book, Evolution of View from the 21st Century. And of course, like McClintock, he was a maverick, right? Where do you see this headed? Because it does seem like the culture of Darwin, the hegemony of Darwinism, is not really changing in a substantial way when it comes to at least the layman understanding of biology, despite us discovering all of these processes which, you know, clearly don't fit the genetic, the selfish gene theory?
How do I see it playing out? That's a very good question. I honestly don't know. I think I think we're dealing well. Let's just say that there are two aspects of moving forward. One is to have or expand the scientific conversation, for example, among scientists, and the other is the kind of public narrative of what evolution and Darwinism is, and this is the thing about Richard Dawkins. He is an eloquent constructor and reinforcer of the Darwinian narrative, and of course, the Darwinian narrative is a very beautiful idea. This is the thing that I think we all have to recognize, that has given, well, actually, that gives any idea its staying power. That is the perceived beauty of an idea. It's so beautiful, it just has to be right, and this happens across human culture, really. In terms of the discussion between scientists, there's a whole political dimension to this. You can see this in the Evolution 2.0 movement, which of course has produced the third way of evolution group. Fascinating group of people, right? With pulling in, philosophers and behaviorists and people like Jim Shapiro, for example, who's a very very good molecular biologist, and that group is kind of a dissident group, right? And we saw this in Massimo's interview with us. That oh well, okay, they're off in this quest, but we don't really need them because we already understand everything, even if we don't really understand everything right now. We will eventually, and I don't know how to break that down. It's a problem that afflicts science generally. It pops up in the most obscure places. So for example, coming back to my own career, my work on macrotermes physiology, termite physiology, and that kind of thing. Basically, undermined a long-standing narrative about the way these things worked that had been established in the 1960s, and it was a similar thing. It was this notion of the air-conditioned termite nest. In case anyone wants to start looking into it, is such a beautiful idea that it just has to be true, and an entire school of thought has built up around it to the point that they were closed-minded about evidence that actually said, no, there's nothing about this that's true. Look at the data, and so this is I don't know. I guess this is an endemic problem in human societies. We are attracted to beautiful things, and if something is coming from without that they perceive as undermining the beauty of that thing, then it has to be shunned. It can't be considered. And I think we need to have a fairly deep conversation among scientists that, well, how do we decide what evidence we want to exclude and what evidence we want to include? And of course, the temptation is always going to be to accept evidence that we like, that bolsters our epistemic bubble. And I don't know. This is a thing with human societies. I don't know how to do it except by basically breaking down these bubbles, or even to the point, the ultimate point of breaking down magisteria, like between science and religion, for example. And that's where fruitful conversations can take place when those epistemic bubbles are opened up. In terms of the public defense of it, there's an entire, I don't know, ecosystem. It consists of science journalists. It consists of documentary makers. It consists of a whole range of science explainers to the public, public relations offices at universities or agencies where scientists work, and the incentives there are to bolster scientific bubbles, not break them down. I don't know if you've seen this or not, but there's an interesting controversy playing out right now in the pages of Science magazine about a paper that was published, I think, 15 years ago that made the argument that there's that arsenic can actually substitute for phosphorus in molecules like DNA. Normally in normal DNA, phosphorus is an important aspect of how nucleotides string together and so forth. And this group of researchers 15 years ago claimed to have evidence that well, actually, arsenic can substitute for phosphorus in there. And when you look at questions like, well, what's the origin of life? Almost anything is possible, right? Anything like that could actually illuminate our discussions of the origin of life. But that resulted in controversy. People didn't like it. There was a lot of social media flaming of this person because it wasn't fitting in. Ultimately, it's ended up with Science magazine retracting the paper where it was originally published, with hurt feelings all around. And this is an extreme example of how the public face of these narratives can actually be controlled by people who aren't scientists. Normally you would take these scientists who made this claim about arsenic in extremophilic bacteria. You'd have some conversations at scientific meetings. There would be shouting and whatnot. It'd be out of the public eye, and somehow you would end up with some kind of pathway forward for everyone. But now it's become this thing with all kinds of stakes that are attached to it, and that stakes that actually shouldn't be there, in my opinion. But it's being reinforced by the way we interface science with the public, and I think maybe some soul searching is needed to actually improve how we present science to the public, because it is a public activity.
Yeah.
At least that's how we justify our existence.
Absolutely. I was thinking that now the article's published and we've done our interview, I'd reach out to Dawkins and see if he's interested in having a discussion with you. I'll send him your discussion with Piglushi, which I hosted, and I was happy to see that Piglushi on, I think it was medium.com or one of his Substack, I'm not sure, online, but he did actually say I was a neutral host, even though obviously I do actually agree with you. So yeah, I'll reach out to him, and I don't think you've had a discussion with him in the past.
No, I haven't. I mean, we've crossed paths at various conferences and have had discussions there, but nothing on your podcast.
Yeah. So yeah, I mean, yours is the only response that's been published so far on this. I'm sure he would like some space to defend his views in a neutral platform. So I'll fire him off an email and I'll let you know what he says, and we'll take it from there.
All right.
Yeah. So thank you for giving the viewers your time. I want to bring you back for the video I sent you of Michael Levin, Nothing in Biology Makes Sense in the Light of Design. A very radical statement, and also his work quite dovetails quite nicely with a lot of the stuff that you've been working on. So it'd be nice to have you back when you're a bit more freed up.
I'd love to.
All right, brilliant. Thank you so much. It's been a pleasure.
And thanks for hosting me, Subur. I enjoyed it.
No worries. Cheers. Bye-bye.
Bye.